So far in chapter 7, they've discussed like 4 different properties, where you have the 0 property, which says x to the 0, or anything to the 0 power, is going to be 1. Then there is the like the negative integer property, which basically says if you have x to like a -2 power, what that means is you put 1 over x to the 2. Or if you had the negative power in the bottom of the fraction, it's now going to be in the top. So when you have negative exponents, you're essentially doing the reciprocal of whatever the base is. When you have the multiplication property, so say you had x to the 3rd times x squared, that's x to the 5th. You add the 2 exponents. And again, it's easier to understand where these properties come from than to memorize. If you have x to the 3rd, you have x, x, x. If you have times x squared, you have times x times x. That's x to the 5th. Then there was the power to the power property, which says you basically multiply those 2 numbers. Again, this is saying x to the 4th 3 times. So you'd have x to the 4th times x to the 4th times x to the 4th, which runs into this same situation where now you've got x to the 12th. Which brings us to section 4. And now section 4 is basically dealing with the division properties of exponents. Division property of exponents. And the division property of exponents says if you have a to the m power and you're dividing that by the same base to a different power, what you're really doing is subtracting. And so here's what that looks like from where this property comes from. Say you have x to the 5th, and you're going to divide that by x to the 3rd. X to the 5th is 5 x's. X to the 3rd, 3 x's. When you're multiplying and you have like something over itself, these are basically canceling, leaving you with x squared, or 2 x's. So that's where it comes from. This is the rule. If you're dividing, you're subtracting. And that should make sense because when we were multiplying, we were adding. Just to give you some examples, these can be really easy or they can get challenging. If you have, let's say, b to the 8th, and I'm going to divide that by b to the 5th. That's just 8 minus 5. It's going to be b to the 3rd. The same thing happens with negatives. Say you have b to the 7th power, and you're dividing that by b to the -2nd. Well, what that means, 7 minus -2. Remember, you have a 7 minus a negative, so that's like adding. You're going to end up with b to the 9th. Here's another way to look at that, though. When you see this -2 in the bottom, what that means to do is move it to the other side of the fraction bar. So what you really have is b to the 7, but then up here you would also have b squared. multiplying. So you can think of it as adding, and there's nothing left in the bottom. So you just have b to the ninth. Here's another example from your book. Let's do m to the 5th power, n to the 4th power, over top of m to the 5th squared n. So the first thing I'm going to do is I notice that I have this power to a power in the bottom there. So I'm going to go ahead and rewrite that. I have m to the 5th, n to the 4th. That would be m to the 10th, and this would be just an n. So when I subtract, what I'm really getting here, m to the 5th minus m to the 10th, is going to be m to the negative 5. This n is like an n to the 1. If you want to put the 1 there, you can. So n to the 4th minus n to the 1 would be n to the 3. The last step is that you've got m to the negative 5, means it's going to go down in the bottom of the fraction, and n to the 3rd is going to stay up top. So that's what your final answer to this problem would look like. It's m to the n over m to the 5. You could also, this is just according to the division property rule. I also found it easier after I got more comfortable with this, knowing that wherever the bigger number was, like on top or bottom, that's where you were still going to have the m's. Like if you think about how there's 5 m's up here, and there's 10 m's down here, then these 5 m's are going to cancel, leaving you with just m to the 5 down here, like the 5 m's are down there. So I started thinking of it after a while as more of a canceling, where I'm left with 5 m's down here, and then one of these n's goes away, leaving me with 3 n's up here. And that might be easier for you, rather than thinking of it as subtracting, as just thinking of it as canceling. So if you had, say, a to the negative 8, b squared, c to the 5th, and then you had a to the 3rd, b to the 5th, c, we'll just do c. Mathematically, what you're doing is you're subtracting. So you have negative 8 minus 3 is going to be a to the negative 11. 2 minus 5 is going to be b to the negative 3. That's a 1. So c to the 5 minus c to the 1 is c to the 4. Since these are negatives, they're going to go in the bottom. So I'd have a to the 11 down here, b to the 3 right there, c to the 4 up top. After a while, another way again to think about it is just knowing like where things cancel. So I know that like these 8 negatives are going to move down here. So that's going to leave me with a to the 11 down here. There's 2 b's up here and 5 down here. So these would cancel, leaving me with 3 of them down here. And then again, it's like a canceling, where this one would go away, leaving me with just 4 of them up here. whichever way you think is easier. Some people really like just subtracting. I get my nice, neat -8 minus 3 is -11. My nice, neat 2 minus 5 was whoops. 2 minus 5 was -3. And 5 minus 1 is 4. And they like this memorizing the algorithm and getting to this answer. Some people like more thinking of canceling. Either way is fine, as long as you get here. I believe there's one more property they talk about in this section. Yeah, it's when you have something like a quotient, like say you have A over B to the n power. This exponent goes to the top and it goes to the bottom. So this is A to the n over B to the n. And again, the reason that happens is because if you had, say, A over B, and say we take that to the third power. Well, what that says is A over B times A over B times A over B. So you've got 3 A's and 3 B's. This is what it looks like mathematically as a rule. So they're going to tell you things like, say you have 5 over x to the third power. You would just make sure that when you answer that, you're doing 5 to the third. 5 times 5 is 25, times 5 again, 125, over x to the third. And I believe then the next section will probably be throwing all these properties together.